Hello and welcome, students. We're going to be looking at function notation today. If you will notice, we have two functions. We have this function f and we have this function g. So there's f and there's g. Our first question asks us to find f of 2. And what that means is they want us to find what f is when x is 2. So in place of x, I'm going to write it 2, so that's going to be 2 times 2 minus 5. I'm going to compute, that would be 4 minus 5. And then I would have that f of 2 is negative 1. And that completes that first one. So let's look at our next one. Our next one says g of negative 1. So g of negative 1 means that I replace all my x's with a negative 1. Note that I want the entire x squared plus 3 times 1 plus 4. Just computing what I have, g of negative 1 would be negative 1 times negative 1, the entire quantity squared, plus 3 plus 4. G of negative 1 is then 8. G of a plus 6. So that means in place of x, I'm going to write this a plus 6, and I'm going to put it in wherever there's an x. So this will be a plus 6 quantity squared plus 3 times a plus 6 plus 4. And then I've got a little bit of algebra to compute because I need to do a plus 6 times a plus 6, and I've got to multiply all of that out. I'm going to go ahead and distribute here. 3a plus 18 plus 4. Working this one out, this is going to be a squared plus 6a plus 6a plus 12. I'll go ahead and combine those two guys. 36 plus 3a plus 22. And finally, I'll get a squared plus 12, 15 a's plus 58. All right, so there's the answer to g of a plus 6. Excuse me, I'll get that. All right, for this next one, they want me to find f of negative 2 and g of negative 1 and just add those numbers. Well, luckily, I've got this one. I know what g of negative 1 is. That's 8, but I don't have f of negative 2, so I'm going to have to go find that. So f of negative 2 is going to be 2 times negative 2 minus 5. That's going to be negative 4 minus 5. It's going to be negative 9. So f of negative 2 plus g of negative 1 is going to be equal to 9 plus, what was that? Oh, 8. So it equals 17. I'll put it right here and circle it. Cool. Now this one is a little different. This one wants me to do f of g of 3. So that means I need to go find, and I like to rewrite them so that the one on the outside is a lot bigger and then I can really see what's going on. So you go deep inside, and I need to go figure out what g of 3 is. So I'm going to do that in a different color. G of 3 is 3 squared plus 3 times 3 plus 4. So g of 3 is going to be 9 plus 9 plus 4, so that's 18, 19, 20, 22. So now that I know what g of 3 is, which it's 22, I just need to go find f of 22 and plug that in. So that's going to be 2 times 22 minus 5. So that's 44 minus 5, and 44 minus 5, f of 22 equals 39. Okay, perfect. Rewriting this guy again, g of f of 3, This says I need to go get what f of 3 is. I don't think I did that anywhere. No, I'm going to have to go get f of 3. So let's find f of 3. That is going to be 2 times 3 minus 5. So f of 3 equals 6 minus 5. That's a 1. So what I need to actually do is go find g of 1. That's the ultimate goal. G of 1 equals, and that's going to be, I don't think I did that anywhere. Nope. 1 squared plus 3 times 1 plus 4. So that would be 4. For this, g of 1 is 8. All right. This is called function composition. When you have right here and right here. When you have functions inside of functions, it's called function composition. And that means you're putting one function in for another function. All right, let's get a few more. And this section is very notational, and you have to understand what the symbols mean and where you put them. And I know it's kind of confusing because this right in here kind of looks like it means f times negative 2. But if f is a function, it doesn't mean that at all. It means f when x is how you would state that. All right, I'll get you some more problems to work. Right, here we have another couple of different types of function problems, understanding the notation. They've given us the equation for this graph, and that equation is f of x equals 7.5x. If they asked me what f of 20 was, I can plug that into the equation. I can say 7.5 times 20, and then do that computation, and I would get 150. Or I can look off a graph and say that when x is 20, y is 150. So I could have just read that off the graph. And I wouldn't have actually needed to have been given that information. Let's look at this. Sometimes you're given a function and it's in terms of a set of ordered pairs. So here they want me to find f of 2, f of 3, f of 2, and f of 7. So let's see what those answers are. When x is negative 2, right here, when x is negative 2, y is 0. When x is 3, y is negative 1. When x is 2, y is 4. And when x is 7, y is 5. Different ways to work with function notation. And it, like I said, is very notational, so if you have any trouble with it, be sure and send me an email. Be glad to hear from you and help you through any of these if you're having trouble. Have a great day.